Hi everyone, so in this tutorial I want to talk about something called TF-IDF, which is, so TF-IDF stands for Term Frequency Inverse Document Frequency. And before I get into that, maybe I'll just kind of explain how I got into this. So I'm basically trying to learn about term frequency, inverse document frequency, and natural language processing. I've been working with it a bit, and I just want to get a better understanding of this stuff. So I thought, well, maybe the good way to start is, try to manually do the calculations of term frequency, inverse document frequency in Python, just sort of program it up myself to better understand it. And I know, Natural Language Toolkit in Python and sklearn in Python are, probably have really good code already to do that. But again, just to try to understand it myself, get a better understanding, I wanted to kind of try to learn it. So with that said, take everything I say here with a grain of salt because I'm also learning this for the first time, and I thought it might be helpful for other people, who might also be trying to learn this for the first time. So if you see, I'd love to get some peer review on this. If there's some experts in mathematics or machine learning out there watching this video and I'm doing something wrong, please let me know because I'm trying to learn more about this stuff and I'd love to take some more advanced math classes or something, eventually to get a really solid understanding. But this is sort of where I'm beginning. So I basically I got a little program in Python working to kind of do this. So we'll see how it goes. But also I found out kind of going through this process, and I just used PyCharm here. Here's the code, and I'll go through step by step all this code here, and I'll demo it in this video too, kind of what it does. It's very simple. So, but anyway, I also kind of was looking at the source code in NLTK and also looking at their GitHub and looking up some issues on their GitHub and stuff. And I thought, when I was first getting started with GitHub, and I mean, I'm still learning lots, but I didn't really know where to navigate or how to look at the source code of Python modules. Like, where do you find that stuff? So I thought that might be helpful for people too who are just getting started in Python. So I'm also going to kind of go through that and stuff because I found something interesting in the NLTK module, which I'll get to later. I had to do a slight modification on the NLTK module that I have on my local machine here to try to get this to work. So hopefully I didn't break it, but I mean, I don't. We'll see how it goes. We'll get to it when we get to it, I guess. But so anyway, that's sort of interesting. So I'm kind of going through a couple things in this video series. Obviously Python coding. There's lots of loops, lots of nested loops. I mean, we'll see how that goes. I feel there could be more efficient ways to do this, but for the sake of trying to understand what's happening, this might be okay. I want to get a little better at linear algebra and multiplying matrices together. Basically turning these strings of words into vectors, I guess. But anyway, there'll be lots of that, and then a little bit of source code, looking at the source code of the NLTK, of Python modules, and a little bit of stuff about GitHub. So it should be kind of a good variety of stuff. Hopefully it's useful, and a little bit of math, I guess. So anyway, without further ado, let's get to the term frequency, inverse document frequency, if you don't know what that is. But essentially, here's the Wikipedia page. And this is sort of what I use to find the formula. But essentially, term frequency, inverse document frequency allows you to see how frequent a word is in a document, right? If you have a document or even just a string like a sentence, how many times how frequent is the word, let's say, for example, universe or galaxy or something. And that will give you information about that document, right? So if the word universe comes up in the document, well, that's sort of useful information about the document because you might be able to start thinking, okay, maybe this is, some sort of space document or whatever, some sort of science document. If the word biology comes up, well, maybe something about biology. But there's also lots of words that are referred to as stop words, I believe, like the and of and it. And there's lots and lots of those words in the English language, especially, that don't really give you any information about the document, right? A news article or a sports article or a science article probably all have the word the many times appearing in the document. And that, I mean, just because that word is maybe the most frequent word, it doesn't tell us what that document is about. But the word hockey or galaxy or biology that starts to give us a little bit more information about the word. So this sort of calculation, this term frequency inverse document frequency, sort of helps us look at all of the frequencies of the terms and see what is the most valuable term that gives us the meaning of the document. So term frequency, the frequency of the words, that probably we get a lot of those stop words like the and is that wouldn't really help. So we want to kind of like offset that with the inverse document frequency, which is the number of times well, we'll get to the calculation here, but essentially that's what it is. That's what we're going to kind of look into here. So that's sort of the overview. And I'm using this sort of normalized one in this calculation instead of just, I guess, what's called the raw count, right? Just counting them, the raw count of the words. I just divided it by the number of words in the document. And then so basically you just get the frequency of each word and divide it by the number of total words in the document, and that's your term frequency. Not super difficult. And then the inverse document frequency is just going to be the number of documents, which is n, total number of documents you can see right here, divided by the number of documents where the term T appears. So well, it'll be easier with the example. So let me just pull up the example here. So to keep this simple, what I've got here is just 3 sentences rather than 3 massive documents, or more likely, more realistically, you might have hundreds of documents. But for the sake of trying to understand this, I just got 3 simple sentences here, which are just strings. The universe has very many stars. The galaxy contains many stars. And the cold breeze of winter made it very cold outside. And why did I choose these sentences? I just wanted to, try to choose sentences that had the same words in them, that had different meanings, and just see what happens with it. And I kept it very simple, all lowercase, no commas or punctuation, because when we start to process this text, if I have, let's say, universe with a capital and universe with lowercase, well, those are going to be considered 2 different words potentially. And for this simple case of trying to understand, we don't want to have to deal with those sort of complications here, because in reality, that's when those modules in Python, or packages, I should say, maybe like NLTK, come in super handy because they can do all of that pre-processing for you. But if we're trying to understand, we can just try to, keep it simple like this. But anyway, what I was trying to say before was for inverse document frequency, if you have the word, the comes up in, like we said, n, right, the number of documents, in this case, so 3 sentences, and how many, n, let's just see here, let me make sure I'm saying this right. So divided by, so the number of documents, in this case 3, right? Because we have 3 sentences, divided by the number of documents where the term T appears. So the appears in all of these documents, right? So it would be 3 documents divided by 3, I believe. But then it's not simply just that. Usually you also have to take the log, and we'll also do that as well. And then essentially, once you've got those 2 numbers, you just multiply them together, and that's your term frequency inverse document frequency. And ultimately, after this, I hope to do something like cosine similarity to actually see how similar documents are, to ultimately do, like a recommendation engine or something. If you've clicked on one article and you want to find other similar articles to that, maybe you can use something like this. Of course, this is very simple, but just to try to get an understanding. So let me just demo what exactly this does, and I won't go too much more into the code because, we're going to get to that in the next videos. But if I run this program here, and let me just run this here. Okay, here we go. So we're going to see some stuff down here. And actually, let me just temporarily comment this code out, just so we don't have too much stuff down there getting confusing. Okay, so essentially here's our result, and I put each of the sentences in a dictionary, a Python dictionary. So you can see this is the first sentence, which is at index 0. And if we kind of scroll over here, you can see index 1. Now, oh, yeah, I'm almost past it. There's the second sentence, and then the third sentence at index 2, which, where the heck? That is right here. Oops. Okay, I don't know why that happened there. Anyway, there's the second sentence, right? Sorry, third sentence. And essentially, these are these sentences here. So the first thing I did was calculate the term frequency, right? So the normalized term frequency, because remember we divide it by the number of words in the document. So for example, the word the, right, appears once in this sentence, and we have 1, 2, 3, 4, 5, 6 words in there, right? So I mean, we can kind of prove this. We grab the calculator out real quick, and we take 1 and we divide it by, I think I said 6 words. We get 0.166666, and you can see there it is. And of course, universe only appears once, so it's got the same value. Has appears once. I mean, you know, so this is not the most ideal data set, but just to try to go through the steps of understanding, you know, it's kind of could be helpful. That's the normalized term frequency. If we did the raw term frequency, I mean, this would be 1 because it occurs once in this sentence. And then I calculated the inverse document frequency. So I guess what I can do here, yeah, this set of code here, all the way down to here, that's where that calculated the normalized term frequency. And this bit of code I'll go through in the next videos from here down to here, calculates the inverse document frequency. So again, in the end, you know, the ended up having a value of 0 because it appears in almost all the documents. So it's not the most useful word for us to look into, right? However, words like universe get, you know, like a value of 1 because they appeared not as often. And then finally, again, we can see that is represented here. I mean, if you take 0 multiplied by 0.16, well, anything multiplied by 0 is 0, so we've got this number. And the TF-IDF, again, right, is these two values multiplied together. So if we take this 0.166 and we multiply it by the 1.09, it should be 0.18. So again, here, if I just whip out the calculator here, we can sort of prove that. 0.166 multiplied by 1.0, so 1.098. Okay, we can just get equal 0.182, 0.183. So that's pretty close, right? I didn't put all the decimal places in there. That's why we didn't get the most accurate number. But there it is. There's the inverse document frequency, I think. Now, again, this may be wrong potentially, but let's, you know, we'll go through it, and please let me know if there is error in my math. So, and obviously, so this next part, I wanted to validate, you know, am I doing this right? So I thought, well, Python has lots of packages, lots of great modules and libraries like NLTK and sklearn. So I thought, okay, I'll use one of those libraries and try to compare it with this sentence. So I chose NLTK in this case. So you can see from NLTK.text import text collection. I've got the documents here. I really don't need to put it here twice, but I did because just to keep it, just to see it easier here, I've just got it here. Again, this is exactly the same as this set of documents up here. And then ultimately I ended up, you know what, I ultimately didn't end up even using it because I just ended up manually putting them in here anyway, because I don't think it didn't work unless I did this like this. So anyway, I make a little object here with this class, text collection class. And then I wanted to see, right, like if we don't need to print the texts here, but if we take mytext.tf-IDF, which is the function, and again, I'm going to go through and show kind of where this source code comes from. Yeah, because it was kind of helpful for me to see it, because I had to make a slight alteration to see this, and I found the issue on GitHub. So again, I'll go through that as well. But essentially how this function works, you pass in the word that you want to get the inverse document frequency on, which in this case, let's go with universe, right? We take this multiplied by this, and then this is the answer. And then we pass it also the sentence that it's in. So the universe has very many stars. And of course, this text collection is aware of all the other sentences because we've passed them in as well when we made the class. So essentially, if this is, you know, if my math is correct, this value should be the same as this value, right? Because this is the word universe. So if we run this, here it is. So we can see that the universe is 0.183102, right, according to my calculation. And then NLTK, and again, take this with a grain of salt, because I did have to make just one slight alteration to the source code to make this work for me. But you can see it's 0.183102, which is exactly the same. So, you know, I don't know, this isn't super validation that this is working, but it sort of gave me a little bit more confidence in the math. And, you know, I would love to get some peer review and discussion on this, because, yeah, I could be making some mistakes here or something. But anyway, this is what we're going to be going through for the rest of this video series. I hope this is going to be helpful to everyone. If you're liking this material, please like and subscribe, and I'll see you in the next video.